Now I have to teach you how to effectively dissolve creatine on water, not caffeine, creatine. And I first stabilize the camera somewhere. I have an idea. Yeah, I think that works. Hopefully. I'm a physics student, so I know what I'm doing. I don't know, physics contains chemistry. Chemistry, sorry. Chemistry. This isn't even chemistry because it's what's called a physical process. It's basically just solving a protein on water. There's no chemical reaction. Let me see. There's just a few creatine here. So the first thing you have to do is put the creatine in the cup. This is a lot. I think it's a lot, right? Oh, there's some here too. Okay. I knew this wouldn't be a good idea. Alright, there's not that much there. So I'm just going to. Can you see it? Yeah. Take here. One. Zwei. Alright. Sorry. It's hard. Tres. Four. Fünf. And finally, cis. Still have some. It's very little. Ideally, I would have to take the rest of it today as well. But it's late at night. It's 8 p.m. already. Okay, so I'm just going to clean the desk first. Just a little creatine on my hands. So the idea here is that since the average cup is too small for this small amount of creatine, because if I'm just adding up to 90 grams on a cup, when I should probably add to 15 grams, almost double that amount, then it's already a small amount of creatine. And there is an equation, by the way, a formula to calculate how much creatine you need per body weight. So let's just add the water. And what you should expect is that just some part of this creatine actually dissolves on water, and the rest should be down here. And then the idea is to drink the part that's dissolved, and of course after this cloudy mixture of dissolved, of not dissolved creatine goes down. Gravity will pull this down, and eventually it will be clear water again. So let's just mix it up. I guess it's right about time to drink it because you can see there's already a layer of clear water here, and there's just too much. It would take a long time for this to settle. Let's do it. It usually takes 3 times. The first one was already done. Proof. An extension of axioms you believe in towards the consistency of a statement. Since a proof is a system of elements called axioms which deductively lead to the statement, a proof can be treated as a model in model theory, and also because of a Curry-Howard isomorphism between math and computer science, a proof is equivalent to a program, and the statement it aims for is the class of that program. Each number is a prime or factor of primes is an example, or class of programs that has a number of programs that prove it. Add up the filter of what the compiler accepts or doesn't accept, and you get yourself a syntactical formalization of a set of program classes, proofs, that can be called mathematics. Now consider these axioms. A false statement is unprovable and a true statement is provable. Due to their tautological nature, they lead to, if a statement is unprovable, then it is false. And if a statement is provable, then it is true. Something provable depends on, again, a consistent extension of axioms towards the consistency of a statement. Truthfulness then boils down to the consistency of a system that is able to prove any true statement. Thus, any set of axioms that can't be used to prove all true statements is necessarily inconsistent. It implies other axioms which it doesn't include are wrong by definition. A consistent system needs to be able to generate all possible elements used in such statements, differentiate a statement from a non-statement, and necessarily have as many axioms as there are. So is there a finite number of axioms that can be used on proofs? No. Of course, this is just an introduction to Gödel's work. I might write more later. All right, uh, it took much less time. Again, one finger here, and it will take probably like 5 minutes to wait at least the other 2/3 of this mixture, powder mixture, to go down. So just drink it now. I still have a little amount of creatine, you see. So what I'm thinking is people who take creatine, they are not drinking enough water to solve it. I'm just going to get more water, by the way. There we go. So you see, it takes a lot of water just to solve half of a dose you should be taking after a meal of creatine. I think it's probably bad to take this amount of water after a meal. I would take it before a meal. Now that I think about it, like 1 hour before a meal. So let me mix it up. Very little creatine now. You can see it's very clear now. An awful lot of water. So the thing here is that because there's such a big amount of water, I would suppose that maybe if you fraction the total amount of creatine that you have to take in a day to smaller portions, it would be better. And also, since when you dissolve it in water, the water becomes as tasteful as water. In other words, it doesn't alter the taste as long as it's dissolved. You could use this water. You could use this, not this water, because if you were going to heat the water, you cannot use it to make coffee, which was my idea. But you can mix it after you made coffee. The only problem is, of course, is that when you make coffee, uh, the water becomes somewhat saturated with coffee elements. So when you try to add more elements like creatine, it doesn't go so well. So a lot of the creatine that would get normally dissolved on water doesn't get dissolved on coffee. So of course, the only solution then, if you want to drink coffee with some creatine amount, is to yell at your loud neighbors. No, is to make a very strong and small amount of coffee, only to mix it later with creatine and water. Of course, the creatine and water were previously dissolved. And it probably is going to work after the third attempt. It's probably something that Have you ever tried to filter only a very small amount of coffee on your coffee drip? I don't think it's very tasteful. Says so in my memory. Oh, that is my ride. I have to go now. Yeah, I have to show you something. Yeah. Have you ever tried to solve this by yourself without ever looking at any solution online? So maybe you should try it. Whoever's watching this should get themselves a Rubik's Cube and shove it up their asses. No, should probably try to solve it in a week. I think that's a fair amount of time. It's very hard. It's very hard. It became famous because it's very hard. And people are very, very retarded and cheaty to go on the internet and learn how to solve it and like just memorize a bunch of movements without even understanding the principle. That's crazy, man.